Okay, so logs just got this exponential equation's a little bit more difficult. If you'll notice, these base numbers are not the same. And when you change the bases, it can only be powers. Like 4 can be rewritten as 2 squared. 8 can be rewritten as 2 cubed. 10 cannot be rewritten as something squared is equal to 20. That's not a thing. So the inverse of exponentials, since I said plural, I'm going to say are logs. All right. And since these base things are numbers, I'm going to write log, but I will tell you the rest of mathematics, they use ln, even though ln is the base e. And I think the only reason advanced mathematicians do that is because that's one less letter to write. So if you're okay with that, I'm okay with it. So what's going to happen is, in order to solve for that n, the only way to get it out of the exponent is to do the inverse, which is taking the log of both sides. I'm going to go ahead and do it this way. I'll just use ln because I think you guys will like writing one less letter. All right? And then this n is going to come down in front because of the properties of logarithms. Now we want to get this n by itself, and it's attached by this ln of 20 multiplication. So we're just going to divide both sides. So n, and this is going to, you have to go out 4 decimal places to the 10,000th place. So then you just type in ln 10, close parentheses, divide ln 20. And what you get is n is approximately 0.7686. And what this means is 20 to the 0.7686 power, you're going to get really, really close to the number 10. Because remember, logs are exponents. All right. Those two bases will not equal each other, so we're going to take the ln of each side. So this x is going to come down in front. X times the ln of 10 is equal to the ln of 29. We want to get the x by itself, so we'll divide both sides by ln 10. So our x is going to approximate, so ln 29, close parentheses, divide ln 10, close parentheses. We get about 1.46, and then the 3 that's there is going to round up to a 4. Okay. This gets a little bit more complex. E to the k subtract 5, we have to get that by itself first. So we're going to divide both sides by 6. And when we divide both sides by 6, don't even worry about putting that into your calculator right now, because in a minute, that's not going to be a thing. Okay, so notice E and 79 over 6 are not the same base. But because this is a base E, we absolutely have to take the ln of both sides. So that's why I said don't worry about doing 79 divided 6. Now, this exponent right here, k subtract 5, I'm going to put parentheses, and it's going to come around in front. So k subtract 5 times ln of e. Well, guess what? The ln of e, remember, the ln, the base is e, and remember what I said, whenever you have a base number the same as the base itself, that answer is 1. So we can cancel that to be k subtract 5 times 1, which is this just k subtract 5. And now we just add 5 to both sides. So k is approximately, so you're going to type in ln, it gives you left parentheses, 79 divided 6, close parentheses, plus 5, and we get about 7.5777. Okay, come over here. We need to get all of this by itself. So we're going to divide both sides by -6. The only thing that we can cancel are the negative signs. That we can definitely cancel. So now we have 7 raised to the 4x is equal to 41 over 6. Now we can take the ln of both sides. And then this thing right here is going to come around in front. So 4x times the ln of 7 is equal to the ln of 41 divided 6. Now we want to get the x by itself. It has a multiplying ln of 7. It also has a multiplying 4. So we could actually divide 4 times the ln of 7, both sides. Well, I don't need to put that in parentheses. I need to put this. So that cancels, the 4 cancels. So x is approximately. So this is a little bit trickier, kind of. But I think we can type it exactly like that. ln, in parentheses, 41 divided 6, close parentheses, divide 4, ln 7, close parentheses, enter. And we get about 0.9349. I'm going to go up and try one last thing. Make sure that the answer is not any different. Ooh, it is different. Okay, so we need to have a double set of parentheses right there. Because this is what happened. What happened is, when the parentheses aren't there, it interpreted it as this. Well, that's not what we want. So we need the calculator to know that whole thing is being divided. And that is about 0.2469. That's why calculator skills are very, very key. All right. So exponential equations, when you have to take the ln of both sides, And then I'll do a separate one for logs.